Next it's time for resistance and Ohm's law. Two things decide how much current flows around a circuit. How hard it's being pushed, so that's the EMF of the cell, and how difficult it is to push current through whatever the circuit's made of, and that we call resistance. We calculate the resistance of any particular thing by measuring the PD across it and dividing by the current through it. You can think of resistance as how much voltage do you need to push 1 amp through the thing. The higher the resistance, the more voltage you need to push 1 amp through. Now what's interesting about this component, the fixed resistor, is that if I double the voltage over it, I double the current. If I triple the voltage over it, I triple the current. In other words, the current through is directly proportional to the voltage across it. This means that the resistance is constant. And this doesn't matter whether the current's flowing one way or the other way. This is actually quite special, and it's called Ohm's law. A resistor obeys Ohm's law when the voltage across it is directly proportional to the current, as long as the temperature stays the same. Other components do not behave this way. A bulb, for example, needs more and more PD to get an increase in current and gives this shape of graph. And a diode, meanwhile, will only have a current in one direction. So it doesn't matter how high you turn up the voltage in the other direction, you won't get a current. If you want to work out the resistance of one of these components, take values from the graph. So for example, for 4 volts, if you want to know the resistance when it has 4 volts across it, take this pair of numbers, or for the bulb, take this pair of numbers. It's only the fixed resistor where you can use the gradient. If you work out the resistance for the bulb at various different voltages, what you'll find is that as the current gets higher, the resistance of the bulb gets higher. So why is that? It's actually because as the current flows through the bulb, it is heating up. It's heating up the metal in the bulb, and that means that the ions are vibrating more. This actually makes it more difficult for the electrons to get through, and therefore the resistance goes up. So how might you get these graphs? Well, this is the circuit that you want to use. And this thing here is your potentiometer. All it is a resistor with a sliding contact. So for example, if you have a 6-volt cell, then when this slider is along here, then your bulb is in parallel with your resistor, and so the bulb will have 6 volts across it. But if you slide it all the way along here, the current it's not going to go through your bulb if it could just go through this wire, which has basically no resistance. So at that point you've got no current flowing through it, and therefore 0 volts across your bulb. So this is the one you want because it gives you a full range, a better range for your voltage.